Am I audible, Kapil?
Yes, you can proceed.
So, good morning to all. It gives me immense pleasure to introduce our esteemed guest for today's online session, training session. So, we are fortunate to have Dr. Nitin Barsne, Assistant Professor at Navsari Agriculture University in Gujarat, joining us today. So Dr. Nitin completed his master's and PhD from IRI New Delhi and has an impressive track record of delivering numerous invited lectures in various training programs. His youthful energy and expertise make him a valuable addition to our session. Dr. Nitin will be sharing his insight on the various sampling techniques utilized in the field of agriculture. Furthermore, today also happens to be Dr. Nitin's birthday, and on behalf of the entire team, we would like to extend our warmest wishes to him on this special day. Happy birthday, sir! So,
Thank you very much. Thank you
sir,
for
without
inviting me.
sir. So, without further ado, I now hand over the platform to Dr. Nitin, sir. The platform is yours, sir.
Kapil, please let me share my screen.
1 second, sir.
Now you can share, sir.
1 second.
Is it visible?
Yes, sir.
Okay. Good morning, one and all. As Kapil and Vijay sir introduced me. So today we will see the sampling techniques using R, in which I will cover few topics: introduction of sampling, basic terminologies, simple random sampling, stratified sampling, cluster, and multi-stage sampling. So basically, what is a sample survey? Sample survey is a method of drawing an inference about the characteristic of a population by observing only a part of population. So this sampling is used in our general day-to-day life also. Like for example, if we go for a blood test, so we don't have to give full blood of our body. That is our population. So we just give to the few drops or few ml of blood for the testing or for characterization of the population of our blood. Just like we want to purchase a rice, so we will take handful of rice from a packet of rice and we will check the quality and we will we will decide that whether we have to purchase it or not. Just like third example is in a household, that mother just want to check the balmness of milk. So she just put few drops of milk on her palm and to check the warmness of the milk. That is the sampling, and which we use in our day-to-day life. Now, why we go for sampling? So there are two situations when in which situation we go for the sampling: when our entire population is not available. Suppose we don't know our population. If we know the population and it is too big, that that studying full population is not so easy. We will not study full population because it will time consuming, it will take cost, it will be hectic. So that in these two situations, we will go for sampling. And after that, we will draw a sample of different size and we will make inferences about the population. So by using the samples, we will study our populations. So there are basically two types of sampling. We will go for probability sampling and non-probability sampling, that we will see later. Now we will go for basic terminologies first. In sampling, there are basic terminologies like population. So as we know that population is the aggregate of observations, means it is sum of all observations. And we have, for example, we can say number of students, number of stars in the sky, number of tillers, total number of books in a library, total number of houses in a place. So these are the example of population which we want to study in our survey. Now there are four types of populations. First one is finite, infinite, real, and hypothetical. So finite population is what? The population which consists n number of observation which we can count. We can count them easily. So I can count the number of workers in a factory, number of farmers in a village likewise. So these are the finite population. Okay, next one is infinite population. So infinite population is what? Which we cannot count. For example, number of stars in the sky. This is the population and this is infinite population. We cannot count. Number of grains in a paddy field. Same example, we cannot count number of grains in a paddy field. Now comes to the real population. Real population is just like a finite population which exists in real. For example, herd of cow and number of students in a class. So this is called as real population. Now we can generate our hypothetical population also. In which situation, suppose in some surveys or some experiment or some research, we don't have real population. So we can generate that population by simulation, or by, we can say, tossing a coin 5 times, we can generate a population of head and tail. So suppose in 5 times we get 3 times head and 2 times tail. So this is our generated population. So these are 4 population: finite population, infinite population, real population, and hypothetical population. Now comes to the sample. So sample is a part of population which will be the true representative of the population. So that should be a true representative of the population. So here I have taken one example in which this Here I have taken an example in which we have considered 50 population size, and we have taken the sample of size n is equal to 8. An individual unit of the sample is called as sampling unit. For example, you are conducting a household survey, and my survey is household survey and family income. If I am going to survey a family income, so I will take the head of family as a earning member, head of the family. So I will take that will be my sampling unit, head of family. So that will be head of a family is a sampling unit, and we will collect the data from head of family only. So this is the survey is, or we can say average income of the family if we want to know. Next one is sampling frame. Sampling frame is very much important for any kind of survey. So we will see that what is the importance of this. So before that, what is sampling frame? Suppose we have a population. Suppose I have a population of size n, and all the size of all the units 1, 2, 3, likewise up to n. This is called as sampling frame. Don't confuse with the name, because in this name sampling frame is coming, but it is the list of all units of the population. A complete, and here it is written that a complete up-to-date list of all the units of the population from which sample has to be taken. So we will take the sample from here. That will be our small n size. So sampling frame is a complete up-to-date list of the population from which we have to select the sample. Why it is so important? It should be complete, should be up to date. Because if suppose, for example, in 2020 election is there, and in 2021 election is also there. Suppose after that, after 2021, we have a voter list. We have different voter lists are there. And suppose in 2020, 100 villagers, 100 vote or 1,000 voters were there. But after 2020, some may be migrated from in the cities, some may be come back to their villages, and some may be died, and some new voters will be there in the list. So that's why this complete and up-to-date list is important for any kind of survey. But if we have a old voter list, suppose for example, if we have a old voter list, so we will get a wrong estimates. We will get wrong estimates. That's why this sampling frame is very much important in any kind of surveys. Now next one is sample space. So if we see the sample space is the collection of all possible samples, and this is called the sample space. For example, suppose we have a population of size population of size 4 and we want to draw a sample of size 2. So these are my all possible samples 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 2, 3, 2, 4. Likewise, we will have total n to the power small n, that is 4 to the power 2, 16 all possible samples will be there of size 2. Okay, now what is parameter? Parameter is the any statistical constant which is defined on the population. So P for parameter and P for population. So you can remember this by using this P for parameter and P for population. So like population mean, population variance, population standard deviation, population coefficient of variation, like these are the all parameters or all statistical constant which we want to estimate from our sample values. Similarly, just like parameter, we have statistic also, and you can remember it by statistic is S for statistic and S for sample. So this is all the sample values like sample mean, sample variance, sample standard deviation, sample coefficient of variation. These are our statistic. These are our statistics, and we will use these statistics for estimating of the population mean, population variance, population standard deviation, and population coefficient of variation. So now whenever these statistics is used to estimate the population values, then it is called as estimator. So estimator and statistics are same thing, but if we are taking single, just like I am talking about the mean only, mean of sample, it is statistics. If this mean is used for estimation of the population mean, then it is called as estimator. And particular value of the estimator is the estimate. For example, suppose we have a population of size n is equal to 4, small n is equal to 2, and our population mean, for example, y bar is some value. I think I'm taking 3.5, and suppose our sample mean is 3.4. So this we are using to estimate this value population mean. Then small y bar is the estimator of population mean. Okay. Now, what is sampling error? Sampling error is nothing but it is the discrepancy or difference between a parameter and statistic. So suppose this is this value is came 3.4 and this value is came 3.5. This is our original population mean. But because as we are not studying all the units of the population, sample will give some average results. So this will, there will be some difference. So I have taken here difference 3.5 minus 3.4, that is 0.1. So this 0.1 is nothing but your sampling errors. And this sampling errors is only present in our sample surveys technologies. In complete enumeration, this is not possible. There is no sampling errors. Okay. Now, what about non-sampling errors? So non-sampling errors are the errors which will present in surveys as well as complete enumeration. Complete enumeration means complete enumeration is also known as, it is also known as population census. It is also known as population census. For example, just like Jangarna, we can go for we can have animal population, animal census also, human census also, crop census is also there. So they, in which each and every unit of the population will be studied. Means one by one we will study, one by one we will go for each and an household, and we will ask that how many population, how many candidates are there in the particular household. So that is called as population census, Jangarna. In Hindi we will say that it is Jangarna. So this non-sampling errors are occur due to collection processing of data. Suppose, for example, I am a surveyor and I have a duty of census. So I have been allotted one village in which 1,000 households are there. Okay, in which 1,000 households are there. So what I have done, I have only went in the 600 house and remaining 400 I have dummy data have kept. So मैंने क्या किया, मैंने that I have done only for 600 household I have studied, and 400 I just skipped and put the data, dummy data I have kept there. So for that, this type of errors, it will called as non-sampling errors, or due to the collection, due to the processing of the data. And suppose I want to feeding the data set in your Excel file. So at that time, suppose some problems are there, some mistake are there in the data set. So then we will say, we will call it as a non-sampling error. But sampling error is present in only sample survey methods. Okay, now we will see that what is the difference between sampling versus complete enumeration. So sampling versus complete enumeration means in this census, we will study each and every population unit. In this census, we will study each and every unit of the population, that is your complete enumeration. And sample, we will take some sample. So what is difference? In sampling, we will have less cost, less time required, population size. Whenever the population size is large, we will go for sample survey. Whenever our population is small, we will go for complete enumeration of census. And sampling error are present in our sampling, but it is absent in census. Likewise, non-sampling error are present in both the samples. Now, next is we will have a different type of sampling. We are having different type of sampling, like probability sampling. So probability sampling is nothing but, probability sampling is, it is a method in which some probability will use. Okay, matlab some probability will having the importance while selection of the sample. So suppose we have a population of size capital N. I am having a capital N population, that is 4, 1, 2, 3, 4 units, and small n I am collecting a sample of size 2. So each and every population unit is having equal and same chance, equal and same probability of selecting in the sample, that is 1/4. So there is importance role of probability in the probability sampling. So all elements in the population have same opportunity of being included in the sample. So that is the role of probability in the sampling. So examples are simple random sampling, systematic random sampling, stratified, multi-stage, multi-phase cluster, and so many sampling techniques are there. Now, what about the non-probability sampling? So there is no importance of the probability at all. Like we will say that on the personal judgment, basis, on our convenience basis, we will select the sample. Suppose, for example, I am studying the population of some city like New Delhi. Okay, and my survey is living standard of the people of Delhi. Okay, so suppose if I want to make the result very good, make good results, so I will take only samples from the posh locality of the New Delhi, just like Defense Colony, Saket. Likewise, we will take the sample from only the society where rich people lives. So my result will be living standard of the New Delhi population is very good. So this is called as convenient. Sorry, this is called as convenient sampling. Likewise, judgment sample is also there, in which on behalf of personal judgment, we will select the samples. Another is snowball sampling. So in snowball sampling, suppose this is me, I have selected 2 persons, I have talked them, and I have told that select two or three person more. So he will select three or more persons. Likewise, our sample will increase. So that is called as, suppose snow is falling and it will collect down and it will increase size. So that's why it is called as snowball sampling. Just like you have heard that chain system, that left side you have to create it, you have to connect two people. The two people will connect more two people. Likewise, this is called as snowball sampling. Similarly, there is another non-probability sampling, quota sampling, in which the samples will be collected on personal judgment, or we can say our convenient and priority based. So that is called as non-probability sampling. Now comes to the simple random sampling. So simple random sampling, in which situation this simple random sampling is used? Simple random sampling, it is used when the population is small, homogeneous, and readily available. Means our population is available to us and we don't know anything about the population. In this situation, we will go for simple random sampling. So we have two types of simple random sampling. First one is simple random sampling with replacement. What is the meaning of with replacement? Suppose you all know that we have in our lottery system, we have different chits here, and we will pick here one chit randomly, and we suppose one number is came and we will give some gift to the selected person. So that is called as simple random sampling. But suppose I have selected a sample. Okay. Kapil, I am audible?
Sir, yes, sir.
Okay. So what is simple random sampling with replacement? So suppose I have selected some unit from here and I have replaced it back to in the population. Okay. So see this example. We have selected unit and unit fifth is selected and we have replaced it back in the population. That is called as with replacement. Okay. So what is the problem here? That the selected unit can repeat. Suppose this selected unit 5 can repeat in another draw. That's why see here in this fourth sample, first sample is selected as 5, second is 7, 5, 10, 7, 5. See here 5 is repeated here. So that is called as simple random sampling with replacement. And each and every population units have the same probability of selection. Suppose there are 10 units, so units will be selected with 1 by 10 probability. Now just opposite to that, what is simple random sampling without replacement? We have selected a unit 5, we will not return back to the population. So again, there will be, all the unit will be independent. So there will be different units in the sample. So that's why it is called as simple random sampling without replacement. We are not replacing it back to the population. Now, which one will be the more effective or efficient sampling? So we will say that simple random sampling without replacement is more efficient than the simple random sampling with replacement, because repeated units are not giving us additional information. That 5 unit is selected 2 times, it will not give extra information or additional information That's why we will say that SRSWOR is more efficient than SRSWR. We can see is by formula also, but I am not going for the formula. It's just that introduction is there. Now comes to the second sampling, that is called as stratified random sampling. Now what is this stratified? Suppose we have, in which situation we will use this? When population is heterogeneous. Heterogeneous means suppose I am having the population, and on the basis of heterogeneity, these are male, female. So we have taken the gender as a character under study. So we will make different stratas like women's and men. So these are now homogeneous. See here, these are homogeneous strata. Here only men's are there, and in here women's are there. So this is called as stratified random sampling. And after making strata, we will select simple random sample by using SRSWOR. So we will draw a sample from each stratum. Suppose for example, we have a population of size 500. Okay, and I have created two strata, male and female. To 300 male and 200 female, for example. And after that, we will select a sample, different samples we will select randomly. And I have selected 10 samples, for example, and 4 samples from here. So this is called as stratified random sampling. So in which situation we will use? We will use this sampling whenever we have a heterogeneous population. Like suppose for example, in agriculture, we have different color of sepals. Like for example, green, dark green, and light green. So on the basis of color, we will make different strata of these different sepals population. So this is called as stratified random sampling. Now there is one allocation of the samples. How much sample we will select? From each strata? That is called as allocation of the sample size. So what is allocation of the sample size? Suppose we have here red color 17, blue color 13, and green color 20, and total population size is 50. So basically there are 3 types of allocation of the samples. First one is equal allocation. Second one is proportional, and third one is optimum. So what is equal allocation? We have population size n is equal to 50, and I want to select a sample of size 6. So what is equal allocation? From each color, we will select same sample size, equal allocation. So we will make 3 strata here. First one is red, blue, and green. Red, blue, and green. So from red, I will select the sample 2, blue 2, and green 2. So that will be my total sample n is equal to 6. That is called a equal allocation. Second one is proportional allocation. So what is proportional? Proportional means our sample size will be proportional to our size of strata. It means size of strata is green is 20, blue is 13, and red is 17. So maximum is green 20. So there will be small n will be proportional to our capital N. Means from that green we will select maximum samples. So suppose here I have selected 1, 2, 3, 4, and from blue it is 1, from red 1. So that is called as proportional allocation. On the proportion of the strata size, we will select the sample. Your third one is optimum allocation. So what is this optimum allocation? In which we will select the sample on the basis that will be Ni is proportional to Ni and Si. So this is our size of strata, means red is 17, 18 and 20 likewise, and Si is nothing but your variance, or we can say what is the variability among them, the stratas. So on the basis of we will select our optimum allocation. Okay, so these three allocations are there in our stratified sampling. Now comes to the cluster sampling. So what is cluster sampling? And there is obviously there is difference between cluster and stratified. So what is here cluster sampling? When there is no sampling frame is available. In earlier I have told you about the sampling frame. If we don't have any sampling frame, I mean we don't have any up-to-date list of the voters, any up-to-date list of the household, any up-to-date list of the forest trees. So in which situation I will go for the cluster sampling, and cost of survey is very high. Suppose cost of survey is very high, so we will go for cluster sampling. For example, this is a village, and we will select the cluster on the basis of neighboring units. So I have created the clusters on the basis of neighboring units. So each and every population unit I don't have to study, but we will select the cluster on the basis of neighboring units. That is called as clustering sampling. So this is our population, and we have created as clusters like randomly I can make a clusters on the basis of neighboring unit, and then we will select a sample of clusters randomly. For example, our population size n is 1000, and we have we have 5 clusters. Okay, and 5 is each size is, for example, 200. Then I will select 1 or 2 cluster as a sample, and we will study each and every unit of this selected cluster. So that is the difference between stratified and cluster. And after that, suppose these are selected clusters. These are selected clusters, and we will study each and every unit of these selected clusters. So what is the difference between stratified sampling versus cluster sampling? So in stratified, suppose these are our strata 1, 2, 3, 4, 5 and 6, and we will select a random sample from each strata. So this is selected, this unit, this is selected. Likewise, these colors are different colors are selected unit from each and every strata. But what is the difference in cluster? The selected cluster, we will study each and every unit of the population, each and every unit of the selected cluster. So that is the difference between cluster and stratified sampling. Okay, next one is systematic sampling. So what is systematic sampling, and in which situation we will use this? Systematic sampling is the sampling in which we have some pattern of the population unit. For example, these are the this is the example. We have different persons here, and we have to select in a row. And likewise, we have different household, and we have to select these household. So target population is arranged according to some ordering or some scheme are there. So what we will do here, we will first select a random unit. Okay, suppose we have n is 1000, and we will select one unit from this randomly. We will select, suppose our unit 65 is selected, or likewise any unit is selected. Then what we will do, we will take our integer value which will divide this unit as complete. Suppose now every third unit, for example, this is our randomly selected unit, and every third unit, first, second, third, is selected automatically by some predetermined pattern. First, second, third, first, second, third. So this is my samples, first, second sample, third sample, fourth sample. So this is called as systematic sampling. So in this situation, whenever we have a household survey and houses are in a row, some arrangement. So in this situation, we will go for, and one more important example is milk yield. Milk yield is there in milk yield experiment or milk yield analysis. We will use this systematic sampling because day wise we are having the milk data, day 1, day 2, day 3, like 305 day standard milking day is there in any cow or buffalo. So day wise data is there. So we will select a random data, like suppose third day is selected, and after that we will select a sample by using predetermined pattern automatically. Okay, next one is multi-stage sampling, and this is very important sampling. Like in our government of India conduct different kind of surveys, like National Sample Survey Office (NSSO), and these NSSO surveys are there, in which, like for example, household surveys are, income surveys are there, crop yield forecasting surveys are there. For example, we can say that general crop estimation surveys are there. General crop estimate, GCES, general crop estimation surveys are there. So these are various survey which is conducted by Government of India, and this survey is conducted by using multi-stage sampling. So what is multi-stage sampling? So in which, suppose I have a first stage is my country, okay, our country. Now on second stage we will select a state out of, suppose for example, now we have different 33 different states, so we will select a state randomly. Okay, this is my second state. Second stage is state. Then from country we will select a state. Suppose I have my selected state is Rajasthan. Okay, then from Rajasthan we will select a, from state we will select a district. So out of so many districts in Rajasthan, suppose we have selected our Jodhpur. So Jodhpur is my third stage district. Out of Jodhpur, after so many talukas are there, suppose I have selected Bilara Taluka. So Bilara Tehsil or Taluka, this is my fourth stage, and after fourth stage, that is we will select a village, and after this selection of village, we will select a household. Okay, so this is called as our multi-stage sampling. This is called as multi-stage sampling. So these are the basic introduction about the sampling. Now we will see some example by using R programming. Just a minute. Kapil, I am audible?
Audible, sir.
Okay. I think it is visible.
Please zoom it, sir.
Okay. Just a minute. Huh? Okay.
Okay, sir. Okay.
So basically, in sampling, suppose we don't have any real population, so we have to generate some random numbers by using this. Different distributions are there. So I will tell you how we will generate some random numbers, and these random numbers should follow some distribution. I think all might have basic knowledge about statistics. There are uniform distribution, normal distribution, binomial, exponential. Different distributions are there. So we have to generate our data set so that it will follow some distribution. If it will have some properties like uniformness. So suppose I am generating random number one, for example. For that, simply we will write Rn random number or one because I will generate so many numbers. Run if. Run if means R is for random, and unif means uniform, UNIF, uniform, and into, suppose I am generating 20 random numbers. Okay, so this will give us a this will give us, just a minute. Okay, so this will give us 20 random numbers. Okay, now these are 20 random numbers, and the range of uniform distribution we have 0 to 1. So this will generate the values between 0 and 1. Now suppose I want to generate 50 random numbers. For example, I have taken here Rn2 run if 50 minimum value is 0 and maximum is 1. So I will just write this script Rn2. You can give any name from in left side Rn. I can suppose 0, comma, maximum is 1. Okay, so this will generate 100 random numbers, and again you have to write this Rn, and this will then we will run it. So this will generate 100 random numbers, and the range of random numbers will be 0 to 1. Okay, now if I want to change it, if I want to plot, so for example, I want to plot this. So I will write plot and into the bracket Rn, which we have generated. So this plot will come. So this will show that how this our random number is generated. And these are the range of data set. Suppose I want to change the color of this. So I will write COL equals to into the inverted commas red and bracket close. So this will give change will color into the red. Okay, so these are the random number generated. Now suppose I want to generate random number between 1 to 10. I don't want the range 0 to 1. So I have just written this Rn3. You can write anything, random number. I suppose I am writing random number into the bracket run if, okay, into the bracket 100, and minimum value is 1 and maximum value is 50, for example. So if you don't want to write minimum is equal to 0, maximum is equal to 1, we can write simple 1 and 50. 1 is minimum value and 50 is maximum. I will run it, and again I have to write this command random number and run it. So we will get 50 random 100 random numbers in between 1 to 50. Okay. Now suppose I want to plot this. Plot random number color red. So this will be the plot of our generated random number. Okay. Now this is what? This is our uniform random numbers. Now I want to generate random numbers that is distributed normally. So suppose normally distributed random numbers, I want to generate 50 random numbers which is distributed normally. Okay. So I have generated N1 and R norm. R norm means random numbers. Norm means which is distributed normally. Just like R uniform, R unif. So I will click on this command. We will generated our 50 random numbers. I will want to see it N1 and we will run it on. So this will be 50 values we have generated. These 50 value we have generated because the range of normal distribution is minus infinity to plus infinity. So we will get here data between minus infinity to plus infinity. Suppose I want to check that this is following normal distribution or not. So I will just make a histogram. So now you can see we are getting it just like a normal curve. Okay, the more clear picture will come. Suppose I want to generate the data with particular mean and variance or mean standard deviation, because we know that the any observation which is following some normal distribution is having mean and standard deviation. Okay, so suppose I want to generate data with R norm and some data size is 10 and mean is 70 and standard deviation is 10. So we will just click on that run and we will write again run and data. So this will generate, see the 10 samples are generated and its mean will be 70 and standard deviation will be 10. These are our generated data set. Now suppose I want to generate 400 random numbers with mean 70 and standard deviation 10. So I will click on it and I will make the histogram. So see here, we will create it as a histogram and this is showing the simple normal curve. Okay, so this data is following normal distribution. So what is the command here? X, I want to generate, suppose I will write it. X is our data set dash R norm. I want to generate, suppose 500 random numbers. Then mean is equal to, for example, mean is equal to 50 and standard deviation 10. You can change it accordingly. Okay, then this will generate 500 random numbers. Now see here, this is 500 random numbers. Okay, now I want to make the histogram. X is my generated data name. Column, suppose I want to give the color of the columns and I have given it blue. And you want to make the border color, suppose border is black. Okay, so this will give a beautiful picture of histogram which we have generated our different sample size, or we can say random numbers of 500, which is following normal distribution. Suppose I want to I want to make curve on this. I want to make the curve on this to plot the curve on histogram. So we have to install the package R companion. Okay. So from where you will install this package R companion, we will go in the package here, and internet should be connected in while we will installing any package. We will install and R companion. So this will give here R companion. I'll install it. Okay, here stop button is there. Until this will clear, it means it is running. Okay, now the package is successfully installed. Now we have to call it from the library. So I'll call it library and into the bracket R companion. Okay, red button is still there. Some processing is also going on. Wait a minute. Okay, now it is installed completely. So we will call it from here also. In this search button, I will search our companion. Now it came here, and we'll just click it on. Now see, it is coming in library our companion. Okay. Now I will generate a vector of our normal distributed random numbers. So suppose I have created x is equal to c. C is for creating a vector. Okay, c is just, we will use this c, like x is equal to c and r norm, and I have generated 10,000, for example. Okay, so this will generate 10,000 random numbers, which is following normal distribution. Now I will click on it. See, this is the 10,000 random numbers. Okay, now I want to draw histogram, and on histogram there should be a curve on it. So we will write plot normal histogram. You can give any name. I can write normal curve. Normal curve. So this will normal curve give, just a minute, plot normal histogram. X is our data set which we have generated. Column red, border black, probability false. and main. This main is nothing but this is the name of your histogram. So I can change, suppose I am changing is here normal probability curve. Normal probability curve. And length is 1000 because now we will run it. See here on the histogram we have created a normal probability curve line. So by this our companion package we can do it. So in any type of that curve you can make this normal curve line, and the normal probability curve is came in. Okay, so this is about your generation of the data. Now we will see drawing a simple random sample using our simple random sampling. Okay. So our objective is to draw of random sample under simple random sampling. Suppose we want to draw a simple random sample with replacement of 5 unit from a population containing 50 units. So our population size is 50 and we want to draw a sample of size 5. Okay. Now suppose I want to generate, I am generating my sample with uniform distribution. So X is my name of sample, C is for vector. So I will write command like X is equal to C, run if means uniform random number, and we will give small bracket. How many numbers do you want? Because our population size is 50 here, so we will generate 50 random numbers. 50, and I want to keep the range from 10 to, suppose I want to keep the range 10 to 80. Okay, so suppose I am deleting it. So this will generate a 50 population unit which is following random uniform distribution, and the range of data set is 10 to 80. Maximum value is 80 and minimum value is 10. So we will run it again. X we will run. Now see here, these are the values which we have generated, 63.68, and likewise we will get our population unit which is following uniform distribution. Now suppose I want to remove this means we can say decimals. Suppose you just want to only integer values. So what I will do, just simply you have to use this floor function. So now for example I am giving the name population POP, then floor and X. Which data set we have generated, we have to make it on floor. So population floor X. So this will remove your decimal numbers. See here, now we just received the integer values 63, 73, 60, 69, 70, 67 likewise. And the range of data set is 10 to 80. Okay. Now I want to generate simple random sample with replacement. That is I have written here. You can give any name in left side. From this symbol, the left side is your, and from and right side is your is our functions. So I have written SRSWR, simple random sampling with replacement. This less than sign dash sample. This is the function inbuilt in R, sample. And from where we want to generate, from this population, we are selecting the sample from this population POP. How much sample size you required? 5 units. So I will have 5, and replace is equal to true. We have to put replacement true because with replacement sampling we are using. So we have to keep replacement true. Okay. Now this will generate a sample of size 5. See here 34, 76, 58, 44, 77. So either you may, the samples may be repeated or may not be. Suppose now, suppose I am generating 10 samples. Okay. See here 77 is repeating now. 77, 12, our sample selected sample is 12, 77, 77, 78, 73, 64, 73, 29, 67, 19. So see here 77 is repeating 2 times and 73 is repeating 2 times. So we are getting the samples which are repeated or with replacement. Okay, so that sample selected with replacement, simple random sampling with replacement. Now I want to generate the sample without replacement. So simply we have to do same procedure. Left side I have given the name SRSWR, SRSWR. You given the name here sample. This is the function in R pop, because we have given the name of population POP, and I want to generate the sample of size 10. Replacement is equal to false. REPLAC, replace is equal to false. In earlier one, we have made the replacement true. That is with the replacement. Now it is without replacement, so we will write replace false. Just a minute. So see here, I have made a mistake. I didn't give dash here, so that's why it is calling error. Now see, it will be okay. So we will generate it. See here 79, 72, 34, 44. 44 is just a minute. We'll select the sample 5. 54, 42, 73, 60, 47. These are my selected sample. Okay, now see here 66, 77. So these are the without replacement sampling, and we can find the mean and variance also. Mean of mean of simple random sampling without replacement. I will write mean SRSWOR. So simply it will give the mean of the data set. Variance, for variance you have to write the function VAR, where into the bracket from which are the sample names SRSWOR. So you will just click it on, then you will get the variance of data set. So these are the mean and variance of our data. Okay, so this is about the simple random sampling. How you will generate the data set. First, random number generation, how we will plot it, and how we will select the simple random sampling with replacement and without replacement by using this R software. Now we will go for stratified sampling. Just a minute, let me take this commands for which one by one we will see. Stratified sampling. So in which we will use the data set which is inbuilt in R, that is called as empty cars, which is the data set on different companies of car. So you will just have to run empty cars, empty CARS, and whenever you just click it on, you will run it. Now see, these are the data set: Mazda RX4, Mazda RX4 WAG. These are different car names. Dustin, likewise Merc, likewise so many car, and these are their variable name: MPG, cylinder, displacement, HP, drat, weight. cubic second, VS, like for example, gear, carburetor. So these are the study variable of different companies of cars. Okay, now you want to see the data set in your data frame. We just write view and into the bracket empty cars. So this will give the data set view here in your script here portion. So you can same data set I can see here also. Okay, now we will attach this data set, attach empty cars. Attach empty cars. So we have attached it. Just like we have seen the sample size allocation into different strata. So suppose we have created two stratas, ST1, ST2 here. For ST1, strata 1 is equal to our original data set or population data set is empty cars. So I will select the data set here, capital bracket, again empty cars, and this dollar sign versus double equals to 1. These are we are giving the conditions which will create a homogeneous stratas and into comma. So this will see here, this is generated our strata 1. Now see, the Sun 710 of few car companies is reduced here. So we want to see the size of strata N1. I want to write N1 sum strata 1 versus equals to 1. So this will give the strata size N1. Now we will see here 14. So total out of this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. 28 or 29 companies data we have created first strata of size 14. Okay, now I want to see the variability in this. So the variability formula S1 is the variability among the strata 1, and this is the square root of variance SQRT, variance of strata 1 ST1 dollar sign. And suppose I want to study the MPG, or you can say you can use any of the variables. Suppose you want to study this displacement, so I can calculate the S1, that is the standard deviation S1 of our variable, that is displacement. So we have seen the N1 size and S1. Now I will create a strata 2. Then for strata 2, again the same script we will write empty cars bracket, again empty cars and dollar sign versus 0, comma. So this will generate our strata 2, and we want to see the size. And see here, these are strata 2 in which different other companies will come, and I want to see the size N2 18. So 18 size is the first of first strata, and 14 is the size of first strata. So total population size is, and 14 plus 18 is 32. So 32 car companies are there, in which we have divided into two different strata. In first strata, there was 14 companies, and in second strata, there was 18 companies. And we have seen the population size here and the variability of both the strata. So these are the variability. If I want to change it, MPG displacement, I will write here DISP displacement. So this will give the variability of your character displacement. See here, in this first data we have calculated the variability of displacement, that is 56, and second one is 106. So we have seen that the variability in second data is more. Now, if we want to use the proportional allocation, so in proportional allocation we have different strata. So our first strata size is 14 and second is 18, right? So on the basis of size of strata, we will select our samples. So sample size strata. So I will write the command like write sample size and stratified sample STRAT SAMP. Okay, then we will give the command. Suppose I want to generate a sample of size 10, and these are the NH is the command for our vector of strata size N1, N2, which we have generated already 14 and 18, and comma, this is the vector of our variability.
कुछ ठीक है ट्रेनिंग के ऊपर चढ़ गए थे मेरे हाँ कुछ दवाई तो नहीं ना
Type, I will write now type is equal to proportional allocation. So we will write PROP. Okay, so here we have want to select the sample by using proportional allocation. Strata sample function is STRAT straight SAMP. Okay, n is equal to 10, NSC, N1, N2. This is the vector of our strata size N1, N2. This is the vector of variability, and type is equal to proportional. So we will run it. Just a minute. We'll run it. R is very case sensitive, so we have to use this brackets. I forget to put this one right here. Okay, just a minute. Okay, we have to install one package here, that is sample survey. Sampling book. Another package is sampling.
I think there is two bracket for the sample size after probe.
Wait, we have to install that software first. Install package, then we will generate it. See, now it is working. So for stratified sampling, we have to install two packages. That first one is sampling and second one is sampling book. Then we will write this command with sample size strata samp n10, and these are the vector of our strata size. This is the vector of our variability, and type is equal to proportional. Now then we will see sample sample size, and we click on it. So see here, from first strata we have to select the sample of size 4, and from second strata we have to select the sample size 6. So you can see that this is proportional allocation because our second strata size is 18 and first strata size is 14. So out of which one strata is having more units, we will select from that strata more samples. So now we have selected the 4 samples from our first strata and 6 samples from second strata. Okay. So suppose you want to change it. Suppose I want to draw 8 samples. Okay. Our population size is 32. Population size is 32, and I want to draw 8 sample out of 32 car companies. So I will just run it, and we will see that from both the strata equal sample size is coming. Okay, so that we can change, or they may be equal, they may not be equal, but in equal proportional, each and every strata we will draw a same sample size. Suppose you can change it here. I want to draw a sample of size 12 from this 32 company cars. So we will get here 5 and 7. So 7 is status 2 is bigger size. So we will generate, or we will draw more samples from strata 2. Okay. Now comes to the optimum allocation. We just write to same. We have to write the same command. Just we have to change the type. Here type is optimum, OPT. Okay. So the optimum sample size we will select. Now we will draw, see here 3 and 7. So these are the optimum allocation which we will use n into s, ni into si. So it will take into consideration strata size as well as your sample, or you can say variability of the strata. So this is about your stratified sampling. Okay, Kapil?
Yes, sir.
I think if we go for means higher sampling technique, so we have to write so much codes and all. So I think it is okay for today's class.
Okay.
So if you have any question or any doubt, you can ask me.
Good afternoon, sir.
Yes, good afternoon.
Sir, if someone has to study a particular state, in particular state and particular district, then it should be a multi-stage one, or it will be a random sampling technique, sir.
See, basically multi-stage is also random. Just wait a minute. I'll again show you. Okay, is it visible?
Yes, sir.
So suppose you want to, you are conducting a survey and you want to know the, for example, I want to study that average yield of rice of particular district, okay, of Rajasthan. So I have selected a district and we will use random sampling while selecting each and every state. Suppose I will, from this country we have population size n is equal to 33 states are there. So we will select randomly by using SRSWOR. So 33 units will be like 1, 2, 3, 4, 5 up to 33. So we will use simple random sampling without replacement. Suppose I want to select two states. Okay. So randomly I will select, I will use any of the method. I will use chit method. I will put all the 33 units 1, 2, 3 up to, and I will pick by closing my eyes 2 units one by one. So suppose my first stage is selected 7 and second state is selected 28. So the serial number which I have given to the state, I will select those random states. Okay. Now suppose my selected state is Uttar Pradesh and Kerala. Uttar Pradesh and Kerala, my state selected. So now I want to study Kerala or Uttar Pradesh or both together, we can study. Suppose I have selected this Uttar Pradesh. Okay. Now I have to select so many districts are there in Uttar Pradesh, like 78 or 80 districts are there. So again, we will use simple random sampling. We will select some district. Then we will go for, I want to select some tehsil or taluka. We will again use simple random sampling. Then we will select the taluka. Then I want to select villages, because in each taluka there are different villages. So I will select again by simple random sampling. So on each stage we have to select the samples by using SRSWOR.
Okay, sir. Sir, in that case, methodology should be a multi-stage sampling, or sir, simply a random sampling?
That methodology will be multi-stage random sampling.
Okay, sir.
And their mean and variance will be different, but our basic sampling technique is simple random sampling.
Okay, sir. Thank you, sir.
Anyone else?
Okay. If you have no query, then let's thank to Nitin sir. And Nitin sir, we are very thankful for such an engaging lecture, and it will definitely helpful for each and every participant. So thank you, Nitin sir, and
Thank
for your
you.
time and effort for such a helpful lecture. Thank you.
Thank you, Kapil.
And participant, we have another class today at, it will start from 2:30. So join at 2:30. Thank you.